Mahalik here for Crystalline Science, teaching you mid-level science concepts. Today we're going to talk a little bit about friction. So up here, I have a couple variables that may or may not affect friction. And so up on the top left, there's a picture of a guy trying to start a fire with some sticks. So whenever you try and start a fire with sticks, maybe you're lost in the woods and in need of a fire because it's becoming nighttime or something like that, you need to be able to move those sticks quickly. The more quickly you do something, or the more speed, if your speed goes up, the friction that you have also goes up. Remember, friction is your ability to stick using microscopic bumps. And so if you speed that up, it's going to have that effect of greater heat. Like if you think about your hands, if you're rubbing your hands together, they might start to get a little bit warm, but if you rub them together really fast, they get hotter, and that's because of friction. And so friction can create heat and smoothness. And so if you rub your hands together really fast, you'll feel both heat, and then afterwards you'll feel like your hands got a little bit smoother. And so that's speed. So that's a direct relationship. When speed goes up, friction goes up. So that's a direct relationship. When speed goes down, friction goes down. Also a direct relationship. Something else we want to talk about is pressure. When pressure goes up, friction also goes up. If you try and, for example, put your hand on the desk or on a table and try and just slide your hand across that table, it'll work pretty easily. But if you put your hand on the desk and then put your other hand on that desk and then add a lot of pressure and add your weight to your hand, it's going to make it a lot harder for your hand to move because of that friction. The microscopic bumps in your hand get stuck to the microscopic bumps in the table or desk. And so when pressure goes up, friction also goes up. That's another direct relationship. Something else we can talk about is roughness, or the textures of the substances that you're putting together. So think about like the tread on your shoes. Here I have a picture of a pair of basketball shoes that have a lot of little ripples in it, and that's so that you're not sliding around the court whenever you try and play basketball and turn and move. You don't want to be slipping. The same reason you wear cleats or spikes when you play football or soccer. So the type of shoes that you have different roughness, and that's important too. So the rougher the texture of the shoe, if that roughness goes up, the friction's also going to go up and make it so that you don't slide everywhere. That's really important. I bought a pair of really cheap shoes once at a discount store, and they had no tread on the bottom, and I was slipping everywhere all day. Not worth the discounted price. So you always have to make sure you have some tread there. At the bottom here, I have a bald tire. Bald tires are mostly used in racing. So when you don't want that friction, when you want to be able to move really fast, like in NASCAR racing, you definitely want to have really smooth tires. And that's going to be a lot different from the tires and the texture on your side-by-sides or monster trucks or trucks that you want to, take mudding through the woods or something like that. They're going to want to definitely have a lot more texture. So you can also think about the texture of sandpaper. If you have something that's really difficult to sand and you want to make it smoother, you need to find a rougher grit sandpaper, and that will give you the results that you're looking for. So when that roughness goes up, the friction also goes up, makes things a lot smoother, sandpaper-wise. So again, those two variables, the side effects, are smoothness. Like if you think about sandpaper, how it smooths down and you have to get a new piece of sandpaper after a while. And also heat. So if you're trying to make a fire, friction could be the way to do that if you don't have a lighter or matches, because it does produce heat, or if you're trying to just warm up your hands. The last thing I have on here is area. Area has no relationship. So it doesn't matter if I have a little piece of sandpaper or a great big full-size piece of sandpaper. It's going to have the same amount of friction. Now the smaller piece I might use up faster, but then I just switch to a new piece. It's going to be the same amount of friction. So if the sandpaper size goes down or up, the friction does not change at all. That's no relationship, not a direct relationship, not an inverse relationship. That's no relationship between those variables. And so remember that friction always opposes motion. So let's say this is, my couch in my living room, and I'm trying to move it, so I'm trying to push this couch, this big yellow block here. If I try and push it, there's going to be a lot of friction moving in the opposite direction. And that would be a type of sliding friction, which has the greatest wear and heat. Speaking of sliding friction, did you know that your knee joints are also an example of this? Let's zoom in here. Okay, so this is a cross section of the joint in your knee. up here I have the femur, the top of your leg there. This would be your kneecap or your patella, and this will be your tibia underneath. And so you have thin layers of cartilage at the end of your femur and at the end of your tibia there. And as you change and move your knee, those things slide against each other, and sliding friction causes the most heat and the most wear. And so sliding friction is also what's going to eat up the cartilage in your knee joints, your elbow joints, your shoulders, whatever sliding joints you might have in your body. And so again, the things that affect that the most are going to be pressure and also speed. And so if you're a runner and you're used to moving these joints very quickly a lot, you might find that your joints wear out faster, and that goes for any athlete, basketball, football, whatever. But if you're moving really quickly, it's going to affect your joints to some degree. Also, if you have a lot of pressure on that, it's going to be harder to slide, just like our hand on the desk. And so people who are overweight, people who are top heavy, even if you have a lot of muscles, they're also going to be wearing on your knees a little bit more. So something to think about. Thank you for watching Crystalline Science. Have a great day. Please subscribe.